Hi and welcome. This time around we're going to take a look at how easy it is and how accurately and repeatably I can find the center of a hole, like this guy right here. But before I start this whole process and test the various techniques I have at my disposal, some of which you may not have seen before, I want to take a look at how repeatable, starting with my indicator, how repeatable is my indicator, because that one of the techniques involves using this indicator. So right now it's on the 15 thousandths. Hopefully you can read that. All right, so I've got a gauge block under here, and as long as I come straight up on the indicator each time, I seem to be able to get within a tenth or maybe even a little bit better repeatability. So you can see it's about a tenth off there. If I were to make a mistake and come in sort of roughly from the side, you can see that went a tenth, essentially 2/10 the other direction. So you need to be careful about how the indicator is manipulated. This is a Michitoyo 5/10 indicator, and it is fairly new. It has not been used very long. So it is a fairly new indicator, and still, you're seeing I'm getting a 1/10 to 2 variation each time. If I zero it out again, now I don't have the world's stiffest setup here. Using a height gauge is not ideal for this. You could go for something stiffer. So this is coming repeatedly a 1/10 under each time until I hit it a little bit hard that time. Now it's a 1/10 over. And I don't know what's moving on this, but I recognize that I might not be able to do better than a 1/10 or 2, which is fine. So it is repeatable, and I don't think Michitoyo specs this for better than 5/10 anyways. All the rest is just gravy, and I'm pretty close to a 1/10 repeatable every time with this gauge block. Next up, I put a block in my milling vise, and I'm going to check the X scale, the glass scale's repeatability with the DRO. So I've got this preloaded to the 15, as you can see there. I went up to my DRO, and I zeroed the X-axis. Now I'm going to come off of the part, and I'm going to come back. Let's see, let's go like an inch or so. And then I'm going to come back, and I'm going to again get this as close as I can. I think my DRO is accurate to 4/10 kind of thing. I think that's what the scales are. I can't remember exactly. And I'm making sure to preload it equally, so only approach from one direction. And my DRO reads 1/10, so that's pretty darn good. Oh, the needle's actually off by maybe that much, and I overshot. Holy cow, that's tight. Overshot. There we go, that's right on. And that's a 1/10. So in my X-axis repeatability, we're about a 1/10. So I'm going to reverse this, and I'm going to approach it with the Y-axis, same sort of thing, and see how repeatable that is next. Because before I do any of this, I just want to make sure my glass scales and my indicator are repeatable enough that I can trust the values they're getting, because if you can't trust those, then everything else, every other technique is going to be limited by the accuracy of your scales. So, all right, that was the X-axis. Let's do Y next. Okay, I'm going to zero my Y-axis now. I don't think you can see this very well. I have no way to get my stand over here, but I'll tell you what the values are. So there's 0. My Y is set to 0 on the DRO. We'll come off about an inch. We'll come back, and DRO reads 0. So that was repeatable to 0, better than a 1/10. So I'd say we're golden here as far as my glass scales on my milling machine, and the indicator here seems to also be repeating since I'm not touching the gauge block, and this is a lot more rigid setup, although this particular gauge block holder is not the best. Yeah, there's 0 again for a second time. All right, for this next test, I have a hardening ground block here. This drill bit is 0.5 millimeter, or about 20 thousandths. I have locked off my X and Y axes on the mill, and we're going to use this carbide PCB drill to drill a hole into this block. I have zeroed my DRO, so my X-axis and Y-axis are set to 0 on the DRO. So we know that this is perfectly centered right here. Full speed on the lathe, on the mill, 40,000 RPM, 4,000 RPM. Solid carbide bit, 0.5 millimeter, like I said, 20 thousandths of an inch. You can see the tiny, tiny hole right there. My mill is still, X and Y axes are still locked off on 0. Still locked off in the DRO, still reads 0, 0. So now what I'm going to do is, holy cow, that was lucky. Bet you couldn't do that again. So I released the drill bit and it slipped out of my hand and it went straight down right into the hole. I don't know if you can see that, but that is one tiny drill bit. It went straight in the hole. First up, we're going to start with the most primitive center finding technique, and that would be using a bit like this carbide one that goes to a point here. And you can see right now with my DRO set to 0, 0, kind of need a microscope at this point. I don't know how well you can see this, but it goes right in there, dead center. So now what I'll do is I am going to unloosen my X and Y axes, and I'm going to take the Y over here and the X over here, and then I'm going to see how close I can get to go back right into that hole. Now this is a very small hole, and I'm starting with this because there's a couple techniques I can use with small holes that I can't use with the bigger ones. So all right, that's about as good as I can get. I would think that would be right, and that is 3 thousandths in 3.5 thousandths in the X direction, 1.9 thousandths in the Y direction. That's still better than I thought I could get with that technique. Next up, we're going to try and find the center of this hole with this spring-loaded standard center finder. It's a two-sided one. Second side can find very small holes. I also have another version of this. This is the 1/2 inch version. I have a 3/8 inch version here. And that looks like get even smaller holes, but we're going to handicap ourselves with the 1/2 inch because that's the most common size I see around. All right, so we're going to start this off the mark. So first, you'll have to walk this guy in and get it close so that at least you can get the point in the hole you're interested in. I think that'll do it. I'm going to put the mill in back gear just so it starts slow. Wow. I have never tried to do this with such a small hole. So you can see when I'm off there, I don't know, that looks about as close as I can get it. Maybe with an indicator, you could use it to get closer, you know, indicate here, go back and forth. But as far as just rotary motion, I've never actually tried this before. That's about as close as I can get. That's 2.3 thousandths by 1.9 thousandths, X by Y, 2.3 by 1.9. So, sort of close, but not super close. Next technique. Next up, we'll be taking a look at the Starrett S828H center finding kit. And we're going to try and find this hole using a similar technique to the one we just did, a wobbling technique, except with a different setup. This is another technique I've never used before. I've had this, but never had an occasion to use it. And I believe what you do is you just, let's get this guy a little off farther out of center than it was. So I believe you just take the needle, get it into the hole you're interested in, and I'm going to lock that off. It also comes with other adapters. There's for slightly bigger holes and for the next size hole up from that, as well as finally a much bigger hole still. So I think initially, let's spin this manually. So I guess manually, actually, I think you're going to need to run this thing, because what you want to see is the bottom part rotating around. Boy, I gotta tell you, I can't easily see it. Okay, that looks vertical to me. That looks vertical to me. That's 28 thousandths and 20 thousandths. I might not be using this completely correctly, but that's about the best I can get. That looks like it's right on to me, and it's way out. So I'm not quite sure how you're supposed to actually pull this one off, because I can't see any motion and it looks vertical to me. I suppose you could measure it, how far off vertical it is. Here's where those solid 1, 2, 3 blocks will come in handy. Okay, that looks good. Let's get this way. Wow, that's out by a million miles. Okay, so this was 1.5 thousandths, 3.7 thousandths, using the crack of light I could see using this 1, 2, 3 block. So I found another use for the solid 1, 2, 3 blocks. That actually worked really well. I should have thought of that from the get-go for lining this up. Yeah. So that worked reasonably well. So that's 1.5 thousandths in the X, 3.7 thousandths in the Y. Next up, I have this turd bake. I got this off McMaster-Card just for this demo. SDA manufacturing, shame on them. This thing is a total piece of junk. It's made out of aluminum everywhere, including the shank where you hold it. And what it is a laser center finder. So you pop this guy in your quill, turn on the laser, and try and get the dot right over what you want. So we're going to see how close we can get. But, you know, this is going to wear, the aluminum's going to wear. You don't want an aluminum shank. They should have at least pressed a hardened shank in there or something. But all of it shouldn't have been aluminum. And then the on-off switch is incredibly cheesy on this thing, as is everything. The laser's pretty well collimated, but there's just this plastic cap sitting on the bottom. Overall, this thing is a piece of junk, and I would not recommend it. I ate $150 for you guys, so you don't have to make this mistake, just so you know. Okay. So you can see the dot right there. It's a fairly small dot, so they did a pretty decent job with that. As you can see here, let me zoom you in. Okay, so it's a pretty small dot. Here's the hole over here, so I'm just going to try and line this up and walk it in. Hopefully you can see this. So I made the hole 20 thousandths diameter, and it seems like the laser is pretty close to that diameter, so that's about the best I can get it. That is 5.1 thousandths in the X, 5.5 thousandths in the Y for alignment right there. But as far as I can tell, that looks like it's right on the hole. There might be an adjustment for this. Oh, this controls how much light. Oh, got it. So you can get it even tighter potentially. That's as close as I can get. That's 1.1 and 2.9. So a little bit better as you reduce the intensity down and makes the dot even tighter. So that's what this cap adjustment does. This thing's okay. I wouldn't recommend it. It would work better with just a little mark on the surface. I put that hole that's 20 thousandths wide, and this beam is fitting inside it, so that's actually nice that it can do that. So that's pretty good. But again, the way this thing's built, if you used it in the shop every day, you'd have it for like a week. One more thing they recommend is right here. To obtain the smallest dot size, For precision work, try coating the material with blue dicam. This coating will absorb a bit of the laser dot, making it appear smaller. Now in my case, I've already got a hole in there. If we're trying this with just a mark on the surface, then you might be able to get a little more accurate with this guy following their instructions. Next up, we're going to try the Fowler centering microscope. This one is made in Switzerland. Oh, sorry, made in England. I'm sorry, totally mistaken there. And they have centering adjustments on this. I don't know if this is calibrated yet, but we'll give this guy a shot. So using this method, I tried multiple times. The first time I was able to get 1/10 by 1/10 off of perfect. The second time it was about 1/1000th off in each direction. So that's not bad considering just using the centerings. And I'm not sure that this guy is calibrated right. There's a process, but I lost the manual and I've got to try and get another one to calibrate this. So I might even be able to get better than 1/1000th by 1/1000th, but this seems to be a pretty good way of doing it. So there you see it centered. And with this method, I was able to get 1/10 in each direction. I was off by 1/10 in the X and 1/10 in a Y, thanks to the center circles. Although I've got to say that Y looks like it could be tweaked slightly. Wrong way. Touchy. After playing with this, I think you could get within 1/1000th in each direction pretty reliably. The last method uses the needle tip on the Blake center finder copy. There's a Fowler. And you can see that's way off. The markings on the indicator suggest 1/2,000th, but I don't know what that equates to at the tip. Okay, there we go. That's really good. That's like 1/10 or 2. And I was better off before I got the motion down there. That is 7/10 and 9/10 for center. Last method is using a dial indicator, and I'm not sure I can get center with this, but you'll notice that this actually needs to be reversed because the dial will be out here, so that's for a large radius. But the beauty is this symmetrical design is we can flip this around, and now we can approach the center. With this indicator, it's pretty hard to keep it in this small hole, so it's kind of challenging. It tends to pop out as you rotate, but it looks like I could adjust this and get it pretty much within a couple tenths, but it's going to take a lot of work, and I think I'm going to need a sharper tip. Well, so I don't think this indicator holder is rigid enough to deal with the tenths indicator, because I'm getting more than 1/1000th play. That's 2/1000th play, 3/1000th. So you got to be very gentle with it, and even then, that's a few tenths movement right there. So it's kind of hard to get this guy centered using this method, especially for this tiny hole with this really long arm on here that goes to a small point. The other problem is that it's got a rounded tip on it. Let's see if you can see this. I don't think you can, but it's got a little ball tip on it, and that ball tip is enough. That ball tip is enough to pop out of this little hole because the hole's not big enough. So you could take this over to a surface grinder and a rotary fixture and grind this to a very sharp point, and maybe you could do a better job. But I think this fixture, the indicator holder itself, is not really up to the task of dealing. This indicator holder right here is not really up to dealing with something with really precise measurements, because there's too much flexion when you just touch this. When you hold this gently, it feels solid, but it's not. You're seeing things move by full thousandths. So you might want to go check out Stefan Gotteswinter's site. He's got a really cool indicator holder that he's designed. For common measurements, this one's fine, but if you want a really precise, rigid one, I think his design's better than this. This has got a really long arm out of it. I didn't try it with a dovetail indicator. This supports dovetail or two different kinds of this long shafted type. This is a pretty long indicator, so a little bit of motion, tiny bit of motion up here is going to translate to a fairly large motion up here. So this might be rigid, more rigid than I'm giving it credit for, because it feels pretty darn solid. But look, with this big lever arm and this big extension, small motions up here will translate to large motions down here where you're actually measuring. So anyways, I've shown a bunch of different methods. I think overall the Fowler microscope method is a really great way of lining up on a small hole, especially when you go through all the process of calibrating the thing. I think it can get very accurate. I did surprisingly well with the conical point. Some of the other methods like the laser, smaller hole would be better and you probably get better measurements. There's a few others. All of them worked, and I think they were fine. The Blake indicator is the most versatile, or the Blake copy that I have my Fowler, because that can do really large diameter holes and small diameter holes all at once. So hopefully this was useful. I'd love to hear your comments down below, so let me know what you think and any other ideas you have on finding the center of holes. I'd love to hear about it. Thanks for watching. Hope you find it useful. Hope to see you next time. By this way, this is an AccuSize indicator holder, if you were wondering.